Alright, so what are we looking at here? Make sure I'm actually recording. I have a moment this morning. Cool, I am. We are looking at 8.4 multiply and divide rational expressions. I love this stuff right here. But I can factor. That has a lot to do with it. For those of you that can't factor, this is brutal. So here's number 2, and I noticed this right here. That is the a cubed minus b cubed pattern, which is going to factor as a minus b, a squared plus ab plus b squared. So there's an x minus 4 up top. To create an x cubed, I need an x. To create a 64, I need a 4. And then I'm going to do this part. I'm going to square the x, a times b, negative 4 times x, minus 4x. I'm sorry, positive, because it's plus. And when I square a 4, I get plus 16. And these guys cancel each other out, become an understood 1. So my result is 1 over x squared plus 4x plus 16. Now, what is my domain? Right here, x could not have been 4. Even though you cross something out, it still affects domain. This stuff right here, all x values are imaginary. So that doesn't affect domain. The big deal is x is not 4. I wrote that wrong. All values of x such that x is not 4. It's everything else. Right underneath it, we got 5 circled. Looks like you're going to have to factor on 5. So I feel my gut says a 4x and a 2x to make 8x squared. And my gut says a 3 and a 3 and a 1 to make the 3. I need to add the 10, so I need this to be positive 12. Take away 2x. Down low, let's go with 3x and 2x. It's one of the reasons you shouldn't do math in ink. Probably a 3 and a 2. There you go. She's factored. I'm going to go ahead and do my domain first. You can't divide by 0. So x cannot be a negative 2/3 right here, because I'm thinking 3x plus 2 is not 0. And x cannot be negative 3/2 right here. So if I like set builder notation, which is easiest to write, all values of x such that x is not negative 3/2 and x is not negative 2/3. And, oh, by the way, what's it reduced to? Well, those things are common factors. So it reduces to 4x minus 1 over 3x plus 2. Some of y'all like show that in one step. Yeah, right. Now, what's up with number 9? Multiply the expressions and simplify the result and give the domain. So it's just more factoring is all it is. So to create this 10, probably a 2 and a 5. An order doesn't really matter because it's just x squared. But we need a minus 5 and a positive 2. Factor the bottom. X and x to create x squared. Factors of 15 being 5 and 3. Minus 5 plus 3. And the reason I'm doing this now is so I can make the multiplication easier. I'm hoping things cancel out. Factors of 21 are 3 and 7. And this is something up high. Remember, it's over and understood 1. So times x plus 3 times x plus 7. Now, before I move on, I'm going to worry about domain. X cannot be negative 3 and x cannot be 5. You have to look at domain before you cancel things out. The plus 3 is canceled, the minus 5 is canceled, and I'm left with x plus 2 times x plus 7. And I may as well do the double distributive property on that. I may as well. X squared plus 9x plus 14 is the simplified result. 10b is highlighted. So here's my two functions off to the left here. I'm just supposed to do f over g. I'm going to go ahead and factor these things real quick because that'll make my life a lot easier. Let's see here. That's x plus 4, x minus 1. This is going to be x plus 2 times x plus 2. This guy, I can pull a 2x times x plus 2. And here I have x minus 3 and x minus 1. I'm not going to do any cancellations or anything until I actually write it down. But I'm supposed to do f over g. This is one of the reasons it says write small. X plus 4, x minus 1, over x plus 2, x plus 2, all over 2x, x plus 2, x minus 3, x minus 1. Remember, you're not ever supposed to divide by 0. So right here, I know I cannot be negative 2. It's part of my domain. Right here, I can't be 3 or 1. And there's another one that's about to show up. It's going to be right here. But you'll see it when you cross multiply. So to divide by a fraction, you multiply by said reciprocal. And right there is a 0. If this piece is a 0, you're dividing by 0. So x is not 0. Anyways, now that I've done the flipping, let's see what cancels. Absolutely nothing cancels. Absolutely nothing. And it would be quite the exercise to work this one out and get it in standard form, so we're not going to do it. We've got an x plus 4 and x minus 3. There's an x minus 1 twice. Down low we have a 2x, and we have an x plus 2 3 times. That's about as pretty as I care to make that thing look. Backside. Number 11. Divide the rational expression, simplify the result, and give the function's domain. So this is f of x, y, z. It's a function with 3 variables. And we're going to find the domain of each one of these things. And it's going to be kind of funky. I'll kind of do it as a piecewise. All values of x such that, all values of y such that, all values of z such that. So if I glance at this thing real quick, I notice that x can't be 0 and z can't be 0 because that would be dividing by 0. X is not 0. Z is not 0. Now I'm going to do division, which means I'm going to actually before I do the division, I'm going to reduce. Just to make things smaller. So I have 8x y squared over z squared. And I'm changing to multiplication, so I reciprocate x cubed z over 10y. Looks fine to me. The problem with using ink is I can't see what was written before. But anyways, I'm going to go with it. A lot of kids will do this first instead of canceling right here. It's fine. 8x times x cubed is 8x to the 4th. Y squared z. 10y z squared down low. And let's see if anything else has shown up. 10y z squared. Y can't be 0 either. Time to reduce. That'll become 4/5. We have x to the 4th up top. There's nothing down low. We have a y squared over a y, so a y up top. and we have a z over a z squared, so a z down low. There's the final answer in all her beauty. What's the next thing we got bolded here? 20. Yeah, 20. Skeletal remains are found to contain 1% of the carbon-14 isotope, which has a half-life of 5,600 years, that of a modern-day human has. Without graphing, express the age of the skeletal remains in exact form. So you guys were taught the half-life formula, principal times 1/2 to the T over HL. That's what you were taught. So something was found, and it is the amount after time because it was dug out of the ground, and it was 1%, which means that originally it contained 100% of its carbon-14 isotope. So 1 equals 100 times 1/2 to the T over a half-life, which is 5,600 years. First step here is to isolate the base of a half. We'll have 1/100th is 1/2 to the T over 5,600. And I'm just going to make it a logarithm. I'm not going to do an ln both sides. I'm just going to make that my base. That's my answer. That's my exponent. It's going to become a log whose base is 1/2. Another reason I question some of y'all's grades, some of y'all don't even write the base little. You just write it right on the same level. Just aggravates the snot out of me. Argument's 1/100th, and it equals T over 5,600. So the issue here is the division. The opposite of division has always been multiplication, unless you're actually, talking about condensing or expanding logarithms. And we'll do change of base here. So we have 5,600 times, this becomes the natural log of 1/100th over the natural log of a half. And then we'll go ahead and we'll follow the rules for breaking apart division within a logarithm. 5,600, set of parentheses, natural log of 1 minus natural log of 100. Close that off. Down low, same thing, natural log of 1 minus natural log of 2. We'll go ahead and encapsulate that in a set of parentheses. And there is the answer, whatever it may be, because it says exact form. If you want to know what it is, push them buttons. So I hope that was as exciting for you as it was for me. If not, sorry.